right, so I don't want to keep you guys in suspense too long, and I want to show you how this is used in terms of functions and calculus. So let's actually begin by just using this in terms of a function. So let's have our function f of x be, I don't know, let's do 4 minus x squared. Simple enough. Okay, let's do the sum from, now this is a really tricky idea that we're going to get into. Let's actually choose some x values that we want. Let's say x1 is maybe 0. x2 is 3. x3 is no, we're not going to be able to do 3. Silly me. Okay, let's do maybe half, and then maybe 2/3, and then maybe x4 be 1, x5 be I don't know, 1.7. Kind of ridiculous stuff all over the place. Who cares? Notice the important thing I'm doing here, and this is important, is that in order, the order is always increasing. So as you notice, these subscripts, these are not powers of x. They're not. Nothing is actually happening to the x. We are just keeping track of specific x values that we care about. But it always has to be increasing. Now, if that idea sounds familiar, yes, that is related to our index. So let's actually just look at how we would write this. Notice what actually looks like an index is down here. And that's, in fact, exactly what it is. This is just a name. This is the 5th x that we would like to deal with. It's not anything related to the number 5, except that is the 5th one that we have chosen. So, in fact, how you'd write this is, let's say I equals 1 to 5 of xi. Now, this is kind of a silly example. We don't actually have the function involved yet, but let's first just actually find the sum or look at what x sub I actually looks like. Well, what this is x1 plus x2 plus x3 plus x4 plus x5. That's it. As you go along, you are putting in the index value in here, and that tells you, okay, now I'm going to use x1, which we have said is 0. And then I would be 2, so I choose the second x that I want, which is just labeled x sub 2. And then x sub 3 and x sub 4 and x sub 5, and all I'm doing is adding them together. Now, this is typically not what we are going to be doing. I just wanted to show you how this new notation on top of the summation notation is going to work. But we could actually find that. We would just be adding 0 plus a half plus 2/3 plus 1 plus 1.7. We could actually figure out what that is. That is not actually what I'm going to do this time. In fact, what I'm going to do is I actually want to find the difference each time. This kind of seems like a ridiculous or perhaps pointless task, but let's actually do it and see what we get. Because there's actually a very cool pattern. So I equals 1 to 5. because I have 5 different x values that I've chosen on this function, of x sub I. Now, I'm going to actually have to zoom in here. This is a very tricky concept. X sub I plus 1 minus x sub I. Oh, goodness. So what are we going to do? What are we going to do here? This is actually going to be tricky. What I'm going to have to do now, because we don't have a 6th one, I'm going to have to drop this down to a 4. You'll see why in a minute. So what I'm doing here is I'm adding together, and I'm changing the index of what is happening here. Let's actually write this out now. So when I is 1, we have x sub 1 plus 1, which is 2, minus x sub 1. This is for I equals 1. When I equals 2, we have x sub 3 minus x sub 2. When I equals 3, we have, well, we could even write in the actual index here. This is what I is, and then I plus 1 would be 4. And then when I is 5, we have, or when I is actually 4, we have x sub 5 minus x sub 4. Now, you may be wondering, why are we doing that? But you might now see why, in fact, I had to drop this down to 4 is because we don't have an x sub 6. So if we actually did from 1 to 5, we'd end up with an x sub 6, and we haven't chosen a 6th one yet. So that's would kind of be pointless. Now, let's look at this and kind of rearrange this, because this will be important later. What do you notice about the actual terms that we have here before we actually substitute them back in? What do you notice about the terms? We have an x2 and a negative x2. We have an x3 and a negative x3. And we have an x4, a negative x4, and a positive x4. So what's going to happen is this one will cancel with this one. This one will cancel with this one. And this one will cancel with this one. And what we're left with is x to the 5 minus, sorry, not x to the 5, x5 minus x1. In other words, 1.7 minus 0 or 1.7. Now, why go into all that? Well, in other words, if you're adding up the different distances between this one and this one, this one and this one, this one and this one, and this one and this one, you should just get the distance between this one and this one. It seems simple enough. Again, we are doing this for a reason. It will get more complicated later. One of the ways that we write this, though, is the sigma from I equals 1 to 4 of delta xi. In other words, the change from one index number to one x number to the next x number that we have chosen. All right. So that's what that looks like. You probably will see this a little bit differently. Yes, we're going to get there. We are going to get there. All right, let's do something slightly different with this as well. All right, so now you know about adding the x values. Let's actually go through and do something with the function itself. We haven't touched the function yet. Let's do Yes, we are actually getting into the calculus part here now. So I'm going to actually draw out a little bit of the function here. Notice this is at 4. No, I can do one more piece before we actually dive into the calculus part. So let's actually do a fun little thing where we add up from I equals 1 to 5 f of x sub I. That's a little bit different, isn't it? This time, what we're going to do is for the given index, we are going to plug that into the function, see what we get out of the function, and add the results up. So before we were taking the difference of x values, now we're adding up y values. It's a very different kind of thing. Remember what this is equal to is this is f of x1 plus f of x2 plus f of x3 and so on. Oof, man, that last one. Okay, here we go. It's bothering me. Okay, so what would this actually give us? Well, this would give us f of 0 plus f of 1/2 plus f of 2/3 plus f of 1 plus f of 1.7. And there we go. That's not all that bad. We are going to get 4 minus 0 squared, which is 4, plus, and I'm kind of cheating here and actually doing the thing, a half squared is a fourth. 4 minus a fourth is 15 fourths, right? For the other ones, I'm actually going to show you what I'm doing. 4 minus 2/3 squared plus 4 minus 1 squared, which is just 3, plus 4 minus 1.7 squared. Now, you might think, well, wait a second, can't we do our little summation tricks? Yes, what we could do is we could, because what we're actually doing, let's actually do this. What we're actually doing is 4 minus x sub I squared. We could bring out the 4, not bring out the 4, sorry, but actually separate this up into two summations, do just the 4 times 5 first and get 20 minus whatever the i's squared are, and that could give us an answer. But because these are irregular, they're not just going up. Even though the index is going up by 1, x value is not going up by 1 each time. In fact, it's different each time, I think. So this actually, the summation tricks aren't very helpful at this point. We would actually just have to calculate what that is. But remember what I said about the y values. Let's actually draw out what's happening here. What's happening for this is before, when we were, here's x1, here's x2, x3 is right next to it, x4 is right next to that, and here's x5. This is 1, this is 2, here's 4. We start at 4, weird stuff happens, right? This is almost 4. This is now down to 3. But what's happening is we are actually doing the y values of the function when we plug in for f of x. So what we are doing for this part at least is adding the y value here plus this y value here plus this y value here plus this y value here. Now that's not really very helpful. What we were doing before, where we were summing up the actual differences in the x values, is we were adding up this distance here plus this distance here plus this distance here plus this distance plus this distance, and it's equal to the total distance. Now I'm going to show you in the next part, why are we doing all this craziness? None of these things are really incredibly useful on their own. I just wanted to have this video up in case the next part is not really intelligible for all of these reasons. So this is just as an extra resource for you to go back to get a little bit better sense of what's happening in the next video. All right, here we go.